Hello everyone. So in our previous video we saw that how we can get a value from a hash table via its key. Now in this video we will see that how we can remove a key from a hash table. So basically we will see the demonstration of remove method which takes in a key and it removes that key from the hash table and also returns its corresponding value back to us. So before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So let's suppose if we are given with this hash table having 3 hash nodes where size is equal to 3. Now let's suppose if we want to remove a particular key. So what we do is, we are given with a key, we first try to find the index associated with that key via our hash function. Then we go to that index and we try to search for that particular key. In case if we find that key, then we simply remove that node from the corresponding list of that index, and if we don't find the key, we simply return null. So here you can see that there are various cases which needs to be handled while removing a key. The first case is what if the key is not present, so we simply return null. The second case is, let's suppose the key is in the middle somewhere. So when we find that key, we can't directly delete this node, because if we delete this node directly, then there are other nodes associated with this node which will also get deleted. So what we do is, let's suppose if we want to delete this key, then when our node will reach to this point, we compare the key and we find that we need to delete this node. We have to break this link. So in order to break this link, we need to somehow access this node, and this is accessed via a temporary node which is previous to our current node which we want to delete. So here, after we find the key which we want to remove, the previous node will help us in removing this node. So what we do is, as previous is pointing to this node, we have to break this link and make a link from this node to currents next, because we don't want to remove the nodes after that. So we simply assign currents next to previous next. So this link will go away and this link will point to currents next, which would be the leftover nodes after we remove this node. So friend, this is also one case where the key which we want to remove is in the middle of this list. So for that we simply keep the track of its previous node, which we will see later. So let's suppose if we want to remove a key having value as 105. So at the first step we pass this key to our hash function, which takes the key divided by buckets.length, which is the number of buckets, and return us back the remainder of it, because here we have this modulus operator. So whatever the remainder is returned, that is nothing but our index where we can find that particular key. So if we divide 105 by 10, we get remainder as 5. So the bucket index becomes 5. We simply access the hash node at bucket index 5. So this will be our head. So as head is pointing to the first node, at the start, we assign a null value to our previous node. So this previous will simply track the previous node to our head. We will see why it is needed later in this video. So currently previous is pointing to null. Now using the head, we will simply search for our key, which we already discussed in our previous videos. So we do head.key, which is 105. We compare it with our key. So here head.key is equal to the key which we want to remove. It means we have to remove this hash node. So what we do is, as previous is pointing to null, it means we want to remove the first node of the list. So currently head next is pointing to null. So there could be a possibility that there are n number of nodes after that. So it means that we want to remove the first node from the list. So what we do is, in order to remove this node, we have to first break this link so that there is no reference to this node and it can be freed up. But we can't directly break this link because there could be nodes after that. So these nodes which can be after the head will also be removed. So what we do is, so first we decrease the size. So size becomes 2. And now what we do is, If we do head.next, we will get the remaining hash nodes in the form of chain. And as head.next is pointing to the nodes after that, if we assign head.next value to buckets at this index, so this node can be freed up and this reference will point to whatever the head.next is pointing. So currently it is pointing to null. So what we do is, if previous is null, which means that we want to remove the first node of the list, so here we will assign head.next value to bucket index 5. So it would look something like this. Head.next is null, so this link will be removed and it will point to null. And now we can simply remove this node and we can return head.value, which is John. So it would look something like this. Now let's say if we want to remove key as 21. So 21 divided by 10 will give remainder as 1. It means the 21 key can be present at index 1. So we access the hash node of index 1. So this would be our head. At start we assign null value to previous. Now here first we search for our key. So we do head.key, which is 31. We compare it with our key, which is 21. So here you can see 31 is not equal to 21. So what we do is, before moving head to its next node, in order to search for the key, we first assign the value of head to previous, because we need to keep the track of the previous node, so that in case if we find a key, then we can use its previous and break the link, so that the key which we have searched can be removed easily. So here, as head is pointing to this node, now previous will point to this node, and we will simply traverse head to its next node via this link. Now we again compare head.key, which is 21, with our key. So here you can see that we have found our key. So our task is to now remove this node. But there could be a possibility that after this node, there are many other nodes. So what we do is, as we want to remove this node, first we decrease the size. So size will become 1. And we simply check whether previous is pointing to null or not. So here you can see previous is not pointing to null. It means that our key is lying somewhere in the between of this list. Because if previous would have pointed to null, then we would have sure that head is pointing to the first node of the list. But as previous is pointing to this node, so what we do is, we simply assign head next value to previous next. So why we do that? Because we need to first break this link. So when this link will be broken, then this node will have no reference, so this can be garbage collected. But there is one problem. Head.next will refer to other nodes as well. So those nodes will also be removed if we break this link directly. So what we do is, head.next will point to the nodes after that. So we simply assign head.next value to previous next. So instead of previous next pointing to head, it will now point to heads next. So this node can be freed up. So it would look something like this. This link will go away, and as head.next is pointing to null, so it will point to null. So now this hash node can be removed easily. We will return the value Tom, and then we will simply remove it. Now friend, let's say we are given with these two nodes and we want to remove 31. So what we do is, we do 31 divided by 10, which gives remainder 1. So bucket index is 1. We simply access the hash node at index 1. We give it a value as head, because this is the first node of the list. We will assign previous a value of null, and then we compare 31, which is head.key, with our key, so that we can search for that particular key which we want to remove. So here you can see head.key is equal to the key which we want to remove. It means we want to remove this key. So first we simply decrease the size, so it will become 1, because we are removing this key now. And after that, we need to break this link so that this node can be freed up. But if we remove this link directly, then all the nodes in this list will be removed. We only want to remove this node, and keep all the nodes after that intact. So what we do is, how can we access all the nodes after that is, we simply do head.next, and if we do head.next, we reach to this node. So here we break this link and we assign a value of head.next to it. So now this link will go away and it will point to this node and the nodes after that. So here we are simply assigning head.next value to buckets array at index 1. So it would look something like this. This link will go away and it will point to this node. And once the method will end, this node can be safely removed and we can simply pass the value associated with this key. So after it gets removed, it would look something like this. So here there could have been multiple nodes after that. So we have kept that list intact and we have removed the node from the middle. So this is also one of the use case. Now let's suppose if we are given with this hash table with 2 nodes and we want to remove a key which is not there in this hash table. So key is 88. If we divide 88 by 10, we get bucket index is 8. We access the hash node at index 8. So here it is pointing to null, which means that key is not present in this hash table. So we simply return null. So friends, these are the cases which are involved when we actually remove a key from our hash table. I hope you find this information useful, and in case if you find this information useful, then please like this video. And if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day.